We are to consider the integral of e to the power rx all over x from 1 to infinity dx, where r is a constant. This r is a constant here, and we are to show that this integral converges for r less than 0. Then indicate any convergence test used. Then the next one we are to show that this integral diverges for r greater than or equal to 0. We are also to indicate any convergence test here. Alright, so this is the given integral from 1 to infinity e to the power rx all over x dx. So with this integral, we know that e to the power rx all over x is less than or equal to e to the power rx, and it is true. If you have e, you know that e to the power rs is equal to what? E to the power rs. When we divide this one by x, then what we are going to get here will be less than or equal to what? This one. So when this is for all s greater than or equal to 1, for all s greater than or equal to 1, then this holds. Alright, so when r is less than 0, from the given question, when r is less than 0, then the integral 1 to infinity e to the power rx dx will converge. This integral will converge by the exponential decay test. So by the exponential decay test, this integral converges. Alright, therefore if we use the comparison test, therefore by direct comparison test, the integral 1 to infinity of e to the power rx over x dx converges. So that is when r is less than 0 here. Then we get to know that this integral converges by the exponential decay test. That is, if you factorize this integral or this exponential function, right, so you see that it converges. So if it converges, then by direct comparison test, this integral will also converge, because this is converging. Alright, so that's then II. Now let's consider when r is greater than or equal to what? 1. So we know that from here, we know that e to the power rs is greater than or equal to what? 1 for all s greater than or equal to 1. So e to the power rs all over x here will always be greater than or equal to 1 over x, and it's true. So the integral 1 to infinity dx over x diverges. This integral diverges by the p test, with what? P equals 1. So by the p test, this integral diverges. Alright, therefore if this integral diverges by p test, then by what? Comparison test. By comparison test, the integral 1 to infinity e to the power rx all over x dx also what? Diverges. Alright, so we can also take another way. Let's take the alternative way. Of what? Solving it. So let's assume for r greater than 0, then we know that the limit as x approaches what infinity of e to the power rx over x is equal to what infinity. Alright, so since the integrand what diverges, this still leaves what r equals 0 case, right? So we consider the case where r is equal to what 0. Now if r is equals to 0, then we are going to end up getting e to the power rx over x, which is 1 over x, which is because r is 0, we are going to get here 1 and then over this x. So the integral what diverges by p test with what by p test. The integral diverges by p test with p equals what 1. Alright, so this ends the solution to today's example. Thank you for watching.